Hi, everyone. Just wanted to take a moment to talk a little bit about distance and midpoints, as that is ultimately what we are going to be doing for this final section of dealing with lines and with graphs. And we're specifically going to be looking at the points, but you could graph all of these on a coordinate grid and be able to find the distance that way as well. So our ultimate objectives are to be able to determine the length of a segment using the distance formula and to find a midpoint of a segment using the midpoint formula. All right, so again, we're dealing exclusively in this case with segments because segments have a defined length. As a reminder, lines go on forever, so therefore we can't really find the length of an infinitely long object. Similarly, we can't find the midpoint of something that goes on forever because it goes on forever in both directions. All right, so what is the distance formula itself? Well, the distance formula itself is if you had 2 points, so if you had 2 points, x1, y1, and x2, y2, what you would do is you would take the x1 and the x2 and you would subtract them and then square them, add them, and then do the y2 minus y1 and square. It doesn't matter which point I call x1 and y1 and which one I call x2 and y2, as long as I'm consistent. So for example, if I had 3, 2, and 4, 6, it doesn't matter if I call this x1 and y1 and this x2 and y2. I could call this one x1 and y1 and x2 and y2 over here. The only thing is we do have to be consistent. I can't do x1, y2, x2, y1. You can't do that. But outside of that, it doesn't matter. So using that logic, when if we look at this problem here that's kind of embedded in it, Tavin claims that d is equal to x1 minus x2 squared plus y1 minus y2 squared. And he's saying he can use that. So yeah, he is correct, right? Because we just said it doesn't matter which one we call which. When we square them, that'll make it positive anyway, so it won't be an issue. As a reminder, we are dealing with distances, and we are going to only be dealing with positives. So when we are squaring things, we are going to get positives, right? So if you have the square root of something negative, something went wrong. You shouldn't have the square root of something negative. Additionally, you want to make sure when you simplify your answer at the end, you use the simplest radical form. So you shouldn't leave something like 40, the square root of 40. You would rewrite that as the square root of 4 times the square root of 10. The square root of 4 is just 2. So you could rewrite it like that. As long as you can plug it in correctly, you'll do fine. I just want to make sure we're clear on our final representation. All right, so where does that actually come from? You're probably looking at it going, well, how did he figure out that if I have 2 points, this is going to be my distance between those 2 points? Oops, it's an X, not a Y. So there's a couple things that you can think about. Number one, right, if you just had a horizontal line, you would have just counted, right? Like if I just gave you that line and you were on a coordinate grid, you would have gone 1, 2, 3, 4, 5, 6, 7, 8, and bam, be done. And you could have done the same thing with a vertical line. So let me actually just finish writing that. This comes from this situation, right? So if you had a coordinate grid and you had 2 points, what would you have done? Well, you could just count, right? You could just count. And then you could also just count up. So when you count to the right and up, what are you originally given here? We're making a triangle. And specifically, since we're counting horizontally and vertically, this just comes from the Pythagorean theorem. All right, so where does it come from? It comes from the Pythagorean theorem. The a squared plus b squared equals c squared. Here's your a, here's your b, we're squaring them. And then over here would be c, except we took the square root, and that's why it's d is equal to the square root of something. All right, so it comes from the Pythagorean theorem, which we're going to do a lot more practice with as we get into triangles. But you've all likely heard of the Pythagorean theorem before, so that is where it comes from. So let's actually do some practice with this. So what are we going to do? We're going to plug in some points. Again, it does not matter which I call x1 and x2. So I'm going to call this one x1, y1, x2, y2, and I'm going to plug it right in. So the distance is equal to the square root. X2 we said was -2 minus 10 squared plus y2 we said was 6 minus a -3. You got to be careful. It's minus a -3. So that is the square root of -12 squared plus, that's 6 minus -3, so 6 plus 3, that's 9. Right? So I get the square root of -12 squared is 144. Remember, you're squaring the negative as well, right? So it's going to be positive. Plus 81, because 9 squared is 81. That's the square root of 225. And that is actually a perfect square. The square root of 225 is just 15. Okay? So the distance between E and F would be 15 units long. And if you were to graph that on a coordinate grid, you'd be able to see it out. And then if you drew the triangle, I think it would be a little bit more clear. All right, let's do another one. All right, so now we're going to find the distance between 7 and -7, -1, and 3, 8. So again, we have our formula there. I'm going to call this one x1 and y1, x2 and y2. Again, it does not matter which one I put as x1 or y1 and x2 and y2, as long as I am consistent. Right? So I get the square root of, that's my x2, 3 minus 7 squared plus 8 minus a -1. Okay. And let's just double check and make sure we did that right. So we have 8, yep, minus a -1, yep, 3, yep, okay. So 3 minus 7 is -4. Don't forget the negative is inside the parentheses, so when you square it, it will be positive. Plus, and then 8 minus, and then a -1, so 8 plus 1 is 9 squared. So I get the square root of 16 plus 81. Okay, so that would be the square root of 97. All right, so you can actually fight with this all day, but there's no way to simplify the square root of 97. So you would just leave the square root of 97 as your answer. So this ultimately right here, even though you're probably looking at it and going, oh, I don't like that, you can leave that as an answer. All right. So let's now look at the next thing that we're going to work on. So now we've just done distance formula where we're finding the length of a segment, but now we're going to find its middle. All right. So what we're going to do to find its middle is we're going to use the midpoint formula. And what I mean by finding its middle is, see how we have our segment here, right here, that's the middle of our segment, right? That's the midpoint. If you were to draw a line through it, it would cut it in half. So if you ever had any line or segment, like a line like that, that line, that one, any line or segment that goes through the midpoint of another is called a bisector. So it bisects the segment. Those are going to be really helpful later on when we're dealing with some perpendicular line applications. But ultimately, finding bisectors can be really useful because you want to find things that go through the middle. All right. And all our midpoint formula is, by the way, is it's x1 plus x2 over 2, and then y1 plus y2 over 2. So we're just finding the average of the x coordinates, and we're finding the average of the y coordinates. Once again, it does not matter which I call x1 and y1, and which one is x2 and y2. This one is just adding. There's no subtracting involved anyway, so it really doesn't matter. You just have to add your two x's together, divide by 2. Add your two y's together, divide by 2. And then whatever your coordinate is at the end, that is your midpoint. So let's look at it. So again, the midpoint, I should use midpoint, okay, is x1 plus x2 over 2, then y1 plus y2 over 2. I'm going to plug that in. So x1 would be 8, x2 is 4 over 2. Y1 is 9, y2 is 3. So we would get 12 over 2 and 12 over 2. So ultimately, this ends up having a midpoint of 6, 6. All that this is if you took your midpoint. I'm sorry, this is if you found, you graphed your line, your segment. We went over 8 up 9. Right? It would be something like that, over 4 up 3. Be like this. So our midpoint would be right in the middle, and that would be the 0.66. It's not always going to happen where they're the exact same number. It's not even always going to happen where they're nice integers like this, where they're 6 and 6. You can end up with a fraction, and it can be a little bit more complicated, but ultimately that's all you're doing. Okay, let's do one more for good measure. So again, the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. And we're going to plug that in. We get 10 plus 7 over 2. And we get 9 plus 2 over 2, which is 17 over 2 and 11 over 2. And I am not going to simplify that. I'm going to leave that as it is. Right? We have two fractions here that don't simplify any further. We have a 17 over 2 and 11 over 2, which would be equivalent to 8.5, and that would be 5.5. So anyway, you can write them as decimals, but I think it's easier just to leave it like this, right? You got your answer, now you're done. That's all. So if you have any questions about distance formulas or midpoints, please let me know, and I'll be happy to answer any questions. Have a good day.